to Science with Bexy, where every episode I take a physics topic and really try and explain it in simple and understandable ways. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode is going to cover Newton's laws of motion. So Isaac Newton was some dude who came up with the 3 laws of motion in like the 1660s-ish. These 3 laws are key to understanding forces and motion. Buckle up, gang. We're about to learn the Newton laws. So, Newton's first law of motion states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. The key point here is that if all the forces acting on an object are all balanced, then there is 0 resultant force and the object will stay still. Or, if the object is already moving, then it will carry on at the same velocity as long as all the forces are balanced and there is no resultant force. So when like a car is travelling at a constant velocity, say 70 miles per hour on the motorway, so you probably need it on cruise control. The driving forces and the resistive forces must be balanced, so there is 0 resultant force. The velocity will only change if there is a non-zero resultant force acting on an object. So 0 velocity or constant velocity means 0 resultant force. On a free body diagram, the force arrows would be equal in size. Ta-da! There we go, that's it. Newton's first law, done. However, if there is an unbalanced force, then the object will accelerate in that direction, which leads us very nicely onto Newton's second law. If an additional external force is applied, then the velocity will change because the forces are now unbalanced. The forces being unbalanced also means that there is now a resultant force acting on the object that is greater than 0. So any non-zero resultant force produces an acceleration in the direction of the force. Meow. On a free body diagram, the force arrows will now be unequal. Now, let me introduce you to the main event. The main feature of the second law is F equals ma, which also means the resultant force equals the mass multiplied by the acceleration. From this equation, we can deduce that the greater the resultant force, the greater the acceleration. So the resultant force and the acceleration are directly proportional. There's something else we can deduce here. Therefore, the greater the mass, the smaller the acceleration. So mass and acceleration have the opposite relationship to resultant force and acceleration. So mass and acceleration are inversely proportional. Sorry, those arrows were really difficult. As always, remember that force is in newtons, acceleration is in meters per second squared, and mass is in kilograms. The SI units. Righto, on to the third law. The end is near. This states that if object A exerts a force on object B, then object B exerts an equal and opposite force on object A. So basically, when 2 objects interact, the forces they exert on each other are equal and opposite. So if you push against something, like a wall, the wall will push back against you just as hard. Weird, right? And as soon as you stop pushing, so does the wall. Forces always exist in pairs, and Newton's third law defines the action and reaction forces. So me pushing against the wall is the action force, and the wall pushing back is the reaction force. So I can see how this might be a tad difficult to get your head around, because if everything exerts an equal and opposite force on each other, then how does anything move? Well, this is where you have to notice that the forces are being applied on different objects, and it's also where Newton's second law, F equals ma, comes into play. Oh, bit of rhyming as well? So, take hitting a ball with a bat as an example. So you swing the bat and the bat exerts a force on the ball. But the ball also exerts an equal and opposite force on the bat. But the ball goes absolutely flying. Hopefully anyways. Whereas the bat will just recoil a small amount. This is because of two reasons. The first being the ball is lighter than the bat, and due to F equals ma, we know that the smaller the mass, the greater the acceleration, so the ball goes soaring. Of course. Still can't see it. And also, we are keeping hold of the bat, so although we feel it recoil, we are applying forces to it afterwards to help control it. There you go! All three Newton's laws of motion. Let's summarise quickly. Numero uno. An object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Numero duo. If there is an unbalanced force, then the object will accelerate in that direction, or F equals ma. Numero trio. If object A exerts a force on object B, then object B will exert an equal and opposite force on object A. Thank you so much for listening. If you like this video and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.